Good morning, everyone. So, up until now in our course, we've really been focused on what you might call static analysis, looking at things like balance sheets or income statements, which are basically financial snapshots of a company at one specific moment in time. And don't get me wrong, that's incredibly important. But today, we're making a big shift. We're moving from the static to the dynamic. We're going to start learning the mathematical language that businesses use to describe change, to identify trends, and to understand the critical relationships between things. This is the language of decision-making, the stuff that lets a manager not just report on what happened last quarter, but build models to help predict and shape the future. So, take a look at this question for a moment. As future managers, you are going to be drowning in data. You'll hear things like, sales are up or costs are down. But here's the thing. As a professional, you can't run a business on vague feelings. Sales are looking good just doesn't cut it. The real questions are always about the numbers. By exactly how much are sales up? What is the precise relationship between the money we're spending on marketing and the sales we're getting back? Being able to answer these questions with real, hard numbers is what separates just reporting the news from making a strategic plan. Today, we're going to learn the fundamental tool for doing just that. And that tool is called slope. Now, I'm willing to bet that for many of you, the word slope brings back memories of a high school math class, finding how steep a line is on a graph. And you're not wrong, but I want you to try and put that purely geometric idea aside for a minute, because in the world of business, slope isn't some abstract concept. It is the language we use to describe the relationship between two business variables. It's the number that tells us exactly how much our costs go up when we produce one more item. It's the language of cause and effect, of inputs and outputs. Okay, so let's get a formal definition on the board. The slope of a line measures its steepness, and for our purposes, the most important part is that it represents the rate of change between two variables. Let's break that down. Steepness is easy to visualize. A very steep line going up might mean your sales are exploding, which is fantastic news. But a very steep line going up could also mean your production costs are out of control, which is a disaster. So the steepness just tells you the size of the impact. The phrase I really want you to focus on, though, is rate of change. That is the absolute key. This idea is what turns a bunch of dots on a graph into real actionable business intelligence. This quote right here really nails it. It translates that textbook definition into what it actually means in the real world. This gets to the heart of the questions your future boss is going to ask you. They aren't going to walk into your office and ask, "So, what's the slope?" No way. They're going to ask, "If we hire 2 more salespeople, how much do we expect revenue to increase?" Or for every extra dollar we put into our digital ad campaign, how many dollars in sales can we expect to get back? The slope is the number that answers those questions. It quantifies that relationship between an action and the result. So this all sounds pretty useful, right? But how do we actually calculate this number? Well, we use a formula. And as we get into the mechanics of this, I want to be really clear. My goal here is not for you to just memorize some symbols for the next exam. The goal is for you to really understand the logic behind the formula. Because once you get what each part of the equation is doing, it stops being a random formula and starts being a powerful tool that you can use for your entire career. This right here is the basic concept. That little triangle, that's the Greek letter delta. And whenever you see it in math or science, it simply means the change in something. That's it. So this formula literally just reads slope equals the change in y divided by the change in x. Now, in business, we usually put our outcome, the thing we're trying to measure, like total cost or sales revenue, on the vertical y-axis. And we put our input, the thing we're controlling, like units produced or marketing dollars, on the horizontal x-axis. So what this formula is really saying is, how much does our outcome change for every 1 unit change in our input? And this is how we actually do the calculation. See, to measure change, you need to have at least 2 data points, 2 snapshots in time. We'll call them point 1 and point 2. Point 1 has its own coordinates, which we'll call x1 and y1. Think of that as last month's data. Point 2 has its coordinates x2 and y2. That could be this month's data. The formula simply finds the difference between the 2 y values and divides it by the difference between the 2 x values. It's the practical way of calculating the change in y over the change in x. And the good news is it's a very simple 3-step process. First, you identify and label your points. And I can't stress this enough. This organizational step is crucial. Most of the mistakes I see happen right here, just from mixing up the numbers. Second, you carefully substitute those values into the formula. And third, you do the arithmetic. It really is a manageable procedure. So let's try one together. All right, let's put this theory into practice. We're going to walk through a simple example using those 3 steps. But then, and I really want you to tune in for this part, we're going to look at the single most common mistake that students make with this formula. Understanding this trap isn't about getting a better grade. It's about developing the kind of careful, precise thinking you'll need when you're making decisions where a mistake could cost a company real money. Okay, here's our data. We have 2 points. So step 1 is to identify and label everything. For point 1, our x1 is 2 and our y1 is 3. For point 2, our x2 is 4 and our y2 is 7. I'm telling you, the best habit you can get into is to actually write this down on your scratch paper. x1 equals 2, y1 equals 3, x2 equals 4, y2 equals 7. It takes 3 seconds and prevents so many simple errors. Now for step 2, we substitute. We take our formula y2 minus y1 over x2 minus x1, and we just plug in the numbers we just labeled. Remember, the change in y always goes on top in the numerator. So that's y2, which is 7, minus y1, which is 3. And the change in x goes on the bottom, in the denominator. That's x2, which is 4, minus x1, which is 2. Notice how we keep the order consistent. The point 2 values come first on both the top and the bottom. That's key. And finally, step 3, we do the math. This part is nice and easy. On top, 7 minus 3 is 4. On the bottom, 4 minus 2 is 2. So our fraction is just 4 divided by 2, which gives us a final slope of 2. Now, even with these abstract numbers, what does that 2 actually mean? It means that for every 1 step you take to the right on the x-axis, you go up 2 steps on the y-axis. That's the rate of change. Okay, now let's talk about that common mistake. The number 1 error people make is flipping the formula upside down. In a test or when you're in a hurry, it's so easy to accidentally put the change in x on top. But look at the difference it makes. Our correct answer was 2. If you flip the formula, you get 0.5. These are not just 2 slightly different numbers. They represent completely different realities. Telling your boss that a relationship is 0.5 when it's actually 2 could lead to some really bad decisions. So just burn this into your memory. It's always rise over run. The change in the vertical y-axis goes on top, always. So far, this has really just been a math exercise, right? We've calculated a number. But we're in a business course, and in business, a number without any context is completely useless. So now we get to the most critical part of today's lecture. How do we translate this calculation into a powerful business insight? How do we take this number, this slope, and use it to make smarter decisions? Okay, let's get out of the abstract and into a real scenario. Imagine you're an operations manager at a factory. This table shows your data for the last 2 months. In month 1, you produced 100 units, and your total cost was $5,000. In month 2, you ramped up and produced 200 units, and your total cost rose to $7,000. Now your boss walks in and asks a simple question. What does it cost us to make just 1 more unit? Let's use slope to give her a precise answer. We're going to apply the exact same formula. Nothing new here. Our y variable, the outcome we care about, is the total cost. Our x variable, the input we control, is the production volume. So the change in y goes on top. That's the cost in month 2, $7,000, minus the cost in month 1, $5,000. And the change in x goes on the bottom. That's the volume from month 2, 200 units, minus the volume from month 1, 100 units. We're using the exact same structure as before, just with real-world business data. Okay, let's run the numbers. The change in cost on top is $7,000 minus $5,000, so that's $2,000. The change in production on the bottom is 200 minus 100, so that's 100 units. So our slope is $2,000 divided by 100 units, and that gives us a final number of 20. But 20 what? And this is absolutely critical. In business, a number without units is worthless. The units here are dollars per unit. That distinction changes everything. And this is the insight you can take back to your CEO. The slope of 20 means that, at least in this range of production, for every single additional unit we make, our total costs go up by $20. This number has a special name in economics and finance. It's called the marginal cost, and this is arguably one of the most important numbers in a company. Why? Because it tells you how to price your product. If it costs you $20 to make 1 more, you better be selling it for more than $20 if you want to make a profit. It allows you to make smart, data-driven decisions on everything from pricing to special orders. This one little number is a cornerstone of running a business. And this tool is like a Swiss Army knife. It's incredibly versatile. We've been talking about costs, but you can apply this logic to almost any part of a business. Plot your sales revenue on the y-axis and time on the x-axis, and the slope tells you your average sales growth per week. Plot revenue on the y-axis and marketing spend on the x-axis. Now your slope is your return on investment.
It tells you how many sales dollars you get for every dollar you spend on ads. The key is to always be clear about what question you're asking, which helps you identify your input, X, and your outcome, Y.
All right, let's bring all this together. We've gone from a simple math definition to the mechanics of the formula and all the way to a powerful business application. Let's just quickly summarize the big ideas and, more importantly, how you're going to use this as you move forward in your careers. These are the points I really want you to take with you today. First, SLOPE is the language of business change. It allows you to speak with precision. Second, it's the engine that turns a boring spreadsheet of raw data into a real, actionable insight. Third, as we saw with our factor example, it is absolutely essential for understanding costs and making smart decisions about profit. And finally, mastering the mechanics and avoiding that simple mistake of flipping the formula, that's not about grades. It's about being a competent professional when real money and real jobs are on the line. So I'm going to leave you with this final question. I want to encourage you, as you walk out of here today, to start looking at the business world through this new analytical lens. Think about a company you follow, or even the coffee shop where you work. What are the key relationships there? What's the connection between the number of customers in line and the store's revenue per hour? You now have the fundamental tool to start analyzing these kinds of trends. And that is your very first step toward thinking and acting like a true business leader.